Hello, this is an example of relative velocity. And as we've talked about in class is sometimes it may be difficult to visualize what exactly it means to say that something has a velocity with respect to another object. So in this case, and also as I mentioned in classes, if you trust the math, then it'll come out. And I think by drawing diagrams of what's going on is also a really good way to visualize it. So we're still in 2D. So in this case, we have two skiers going down a slope. We have this skier here. Sorry, it's a little hard to read. 30 feet per second on a slope of 10 degrees. And then a skier behind them going at 45 feet per second. And they're at a slope of 25 degrees. So we want to find the velocity of A with respect to B. So we know that the velocity of A with respect to B is equal to the velocity of A minus the velocity of B. And so that's a pretty standard relationship that we've been talking about for some time now. So we can go ahead and rearrange that to velocity A equals velocity of B plus the velocity of A relative to B. So using this, we can draw our triangle, and this allows us to visualize what's actually going on. So up here, I have the velocity of A, and we know that that's equal to 30 feet per second. And then I've drawn another line here at 25 degrees. So I know this entire angle up here is 25. So if that's 10, then this has to be 15. So 10 plus 15 is 25. All right. Sorry for it's not super clear. I'm having trouble getting it to focus real well in this light. So now we know that. And so if this is velocity of B, then we know that we just do tip to tail, and we can draw this back here. And there's our velocity of A relative to B. Okay. So you can solve this two ways. You can use the law of sines, law of cosines, and figure it out from there, or you can just add the vectors together. So let's start using the law of sines, law of cosines. Now, one of the things that we have is we know the angle between these two sides. And so because we know that, that's good for the law of cosines, because generally with law of cosines, if you know the magnitude of this side, the magnitude of that side, and the magnitude of the included angle between the two, then that allows us to solve directly for the velocity of A relative to B. So if we do that, we get velocity of A relative to B squared equals velocity of A squared plus velocity of B squared minus 2 velocity of A, velocity of B, cosine of the included angle, which is 15 degrees. So what I end up with then is 30 squared plus 45 squared minus 2 times 30 times 45 cosine 15. And that's all to the 1/2, and that's going to equal BA relative to B. Okay, so my BA relative to B magnitude is 17.80 feet per second. Now, we need to figure out, though, the direction. Now, we see the direction here, but we want to know what is the actual angle. So in order to do that, we're going to need to find out what this angle is here. So because then we can draw a symbol for the angle, and this will be 25 plus whatever that is. So we know that VB, we know that the angle opposite of this is VA. So we can say that 30 over the sine of this angle, we'll just call it theta has to equal, and we can just do, use VA relative to B. So 17.80 divided by the sine of 15. Okay. So all I did was I looked at this opposite side, right? So I knew that angle. I knew that magnitude from here. And I knew velocity of A, which was the opposite side to that angle there. So I get an angle theta equal to 25.85. So this whole thing, because remember when we always do direction, we always do it to a X or Y axis. So if we do that whole entire angle, sorry, it's, let me rewrite that a little neater. And this angle will be 25.85 plus the 25 here. So we get a total of 50.85. Round our sig figs, 50.8. Okay? You don't round up when this number is even. That's kind of a special rule. If you've had 236, you have seen that, but for you other majors, if you have an even number followed by a 5 and nothing beyond it, then you round down. If this is an odd number, like a 7, then you would round up. So kind of an interesting rounding rule. So 50.8 degrees, there we have it. So that's one way to do it. I think it's fairly straightforward. If you so desire, you could also just subtract the two, in which case, if we were to do that, we would break these into their respective pieces. And so if I were to do that, let's, so we can keep this here. So we still have this at 25 degrees. You could tell that I minored in art. So here's my VA relative to B equals VA minus VB. And so now if I draw my vector, I have what? 30 cosine 10 degrees I minus 30 sine 10 degrees J. And that's all subtracted with 45 cosine 25 degrees I minus 45, sorry to run out of space, cosine sine 25 degrees J. So we end up with negative 11.23 I plus 13.81 J, which if we take the magnitude gives us 17.80 feet per second. And if we find the angle of that, which would be, it would be a positive J, so it would look like this again. It would be up and like this. So that angle there, if this is 13.8, and that's 11.23, so we have inverse tangent of 13.8 over 11.23 equals our new angle. We'll call it, we used theta before, so we'll just use phi. So phi again, if you do the math, is going to be, surprise, 50.8 degrees. Okay. So some of you might find this easier. Some of you might do the triangle. Either way works fine. So that's hopefully makes sense. So that's, again, when you look at a problem like this, it's very straightforward. And again, the concept, once you get this piece here, then the rest is just fundamental math. Okay, hope that helps. See you in class.